All right, welcome to lesson 3 for chapter 13. We're going to talk about soil conservation in this lesson. So learning goal is that you will be able to describe soil conservation techniques. So we've talked about a little bit of how we classify soil, how soil is formed, a little bit about why it's important, and now we're going to talk about how we save it. So, success criteria. By the end of this lesson, you should be able to define erosion, describe how erosion affects agriculture, describe the effect of losing topsoil, and identify the agricultural potential of the U.S. versus the world. So how much potential do we really have for agricultural use in the U.S.? So erosion is the wearing away and transportation of soil by wind, water, or ice. Worldwide, erosion removes 25.4 billion metric tons of soil per year. That's a lot. This is made worse by deforestation and desertification. And then poor agricultural practices also increase erosion and lead to the transport of associated fertilizers and pesticides. So plants help keep soil where it is. So soil is there for plants to grow in, to support plant life. If you take the plants out of the soil, there's nothing holding it together. It just is kind of loose soil, which is why erosion is made worse by deforestation and desertification. When it starts to dry out, if you had a pile of mud versus a pile of dried dirt, the dirt is going to go away faster than the mud would. Most current agricultural practices lose soil faster than it can be replaced. Wind erosion may not be as evident as water erosion, so you can't see it really as easily, but it's still very serious. And it's most common in dry, treeless areas, because again, dry dirt or soil is going to blow away a lot easier than wet. And then if there's treeless, if there's no trees, there's nothing to block the wind. The Great Plains of North America, hello, that's us, have had 4 serious bouts of wind erosion since the European settlement in the 1800s. So when topsoil is lost, why do we care? When topsoil is lost, fertility is reduced or destroyed. Remember that topsoil is where those nutrients are. So if we lose it, we have to artificially restore that fertility. So that's using fertilizers, and fertilizers have their own issues. So this practice can also raise food costs. If a farmer has to put more fertilizer down, they got to pay for it somehow. And that also increases sediment load in waterways. Nothing that you artificially put into the ground is going to just stay where it is. When it rains, when there's wind, it's going to move and get into the waterways. So over 20% of the U.S. land is suitable for agriculture, but only 2% does not require some form of soil conservation practice. Which means all of the 20%, only 2% of that doesn't need us to be doing something to save the soil. So for agricultural potential, if we look worldwide, 11% of the land surface is suitable for crops. So just over 10% of the world is suitable for crops. An additional 25% is in permanent pasture, so which means raising animals versus growing crops. In the U.S., almost double what the world has, not like in land size, but in percentage. 20% of the land in the U.S. is suitable for crops, and 25% is in permanent pasture. We are in a really good space to grow food if we can protect our soil. If we compare to the African continent, only 6% of the land is suitable for crops, and 29% can be suitable for, or can be used for pasture. So a lot more area is suitable for raising animals versus crops. So if we look at soil conservation practices across the globe, the lighter it is, so the coloring is metric tons of silt per square kilometer per year. So silt transportation in some of the world's largest river basins. Erosion is greatest where a great deal of silt is carried away by the rivers. In these areas, the fertile topsoil, which forms the basis of agriculture and pastoral production, disappears. So the lighter it is, the less it is, and the darker it is, the more. And we can really clearly see usually when there's poor versus proper soil conservation practices. This right here, they're losing a lot of soil as that water flows down. Here we have some terracing happening and some windbreaks that are protecting that soil a little bit more. All right, that was a very quick lesson 3. Let me know if you have any questions, and I will see you in the next one.